I believe it was millimeters.
Millimeters. So you can select millimeters and then select OK. So this basically imports the STL geometry that you have. And I'm going to click on shaded viewport here, and that basically shows it in a rendered or shaded view. Okay.
Okay.
So there's the orthotics part that you had. And if you take a look at it, you can view it from different views. You can go ahead and click on 4 views. It shows it from looking down from the top. This is a perspective or isometric view. This is from the right front and then from the right side. So you can work in multiple views, or you can just maximize it to a single viewport.
Okay.
All right. Now, so you're going to be looking at creating the mold cavity from this part. Is that correct?
Well, you know, ideally we would take actually a scan of the foot, and the file that would actually open would be a file of a foot, not the file of an orthotic.
Okay. Okay.
But can we mill out a positive mold off this orthotic?
You will have to create one. We wouldn't be able to. You have to do that in Rhino. As far as machining goes, we'll be machining what we see right here.
Okay.
Now, if you're looking to machine like a positive mold of a foot scan, let me see if I have something I can load it. I can certainly do that once I show you how we can program a part like this. Then we can take a look at it. Okay.
Sounds good.
All right. So there are tools in Rhino as well as there, that you can use to build, mold, mold or mold cavity with it. So that's part of the CAD design. But if this is what you imported, we can go and directly machine this part. Okay.
Okay.
So the typical workflow here is once you open the part, you want to make sure if it's in the correct orientation for machining. So we want to make sure that your mill or router has enough travel on the x-axis to fit this part to be able to machine it. If you need to reorient the part, you have tools to rotate it. So I can select this and say I want to rotate this by 90 degrees or the other way around, so I can rotate the part. Okay. So to fit it on the machine tool. Now, do you know what type of machine and controller you have?
Well, we have a it's a smart shop. It's a smart shop. We bought it at Laguna. I think you guys do business with them. So it's a smart shop M2.
Okay. And is it a 4x8 or 4x4? What kind of travel do you have on the machine?
It's a 4x8.
Okay. So 4 is on the X and 8 is on the Y, right?
Right.
Okay. So for this part, if you take a look at the overall size or dimensions, it is about 166 millimeters on the X, 179 on the Y. So you could machine it either way, whether you wanted to keep it the way we imported it, or we could rotate it because it's going to fit within the work envelope of your CNC table. Okay.
Okay. Okay. So, and let's see if normally each foot scan is separately. Would we be able to reposition the each orthotic?
Absolutely. You can use the tools in here to drag and drop it however you want.
But not just let's say right versus left. Could we put the heel on the other side on just one?
Yeah, 180.
Oh, okay. Okay. All right. Excellent.
So you want to basically minimize the material wastage.
Right.
Yep. You just rotate it. You have tools to do that in Rhino, so you can reorient it. So you want it to basically maximize the efficiency.
Yes.
Yes. So what we did was I rotated this by 180 degrees.
Okay.
Okay. So you can rotate it. Okay.
Yep.
Now let's go ahead and create our workpiece. I'm going to choose stock, box stock, and I'm just going to go ahead and round this off like 200 millimeters by maybe 175 millimeters. Okay.
Okay.
And then I can give it a height or thickness, whatever the thickness of material you typically would be starting with. It's going to be 35 millimeters or 50 millimeters or whatever that is, right? Standard, or you may have certain size material. So at least we need 30 millimeters or 31 millimeters. I'm going to say it's 35 for our demonstration purposes here today. Okay.
Okay.
So we can define the stock in here. That's the workpiece stock blank size. And then we want to align it. So I can say align the stock, and I can have the stock position in the center in X and Y. And then for the Z, we can pick top, center, or bottom. So if I pick top, the top, you know, of the part is flushed with the top of the stock. If I pick bottom, the bottom of this is flushed with the bottom edge. So you can even have it centered. So it leaves uniform material on the top as well as at the bottom. So you have different controls on how you want to do it. Okay?
Okay.
All right. So now once we are through with this particular step, we can go ahead and specify where you like to put the 0, 0, 0. You can either put it to one of the corners of the block of material that you're going to be working with here, to one of the corners, and then the top or the bottom. So to do that, you can do align, set world coordinates, set the origin to the stock material. So you can see it's setting to the corner of the stock. Highest Z will be the top edge, top face. Southwest will put the 0 right to this corner right here. Okay. And then we'll pick OK, and you'll notice that the origin is being set to the top of the stock in the Z, and then it's set to the lower left corner, which is the southwest corner.
Okay.
Any questions so far?
No.
Okay. Now we wanted to machine these two features in here. What I'm going to do here is we'll create some tools. I already have some tools loaded in here, but I'm going to unload this tool, and we'll go ahead and look for a tool in here. Let's see if I can find some tools. Millimeter library, I'm going to load it. So I have a library of tools loaded, or you can build your tools as you go along the process. If you do not have a library created, you can create tools of different types like ball mill, flat mill, corner radius tools for engraving, chamfer, taper, thread mill, face mill. You have different types of tools in here, even for drilling, center drill, reamer, tap bore, reverse bore. Typically for parts like these, you'd either want to begin with a flat mill for roughing, and then a ball mill for finishing. If the material you're cutting is going to be fairly soft, like foam or something like that, you can go directly to a finishing process. You don't even need to do a roughing process. Okay?
Okay. All right.
All right. Now, I would only want to cut around the shape of the part and not turn everything around this into chips. So one of the things I'm going to do here in Rhino is a command called create an outline. There's a command called mesh outline, curve from objects, mesh outline. And I'm going to drag a window to select these, press enter. You can see that it creates like a boundary around the part.
Yes.
Okay. Now this boundary can be used for limiting or containing the tool path, the cutter path to this area only. So now let's go ahead and program our machining operation here. We've set up the machine. We could select the post processor either at the start, or we can do it just before when you're ready to send to the machine. So we have posts for a wide range of machines, and we can see there are several different posts for Laguna as well. So since you mentioned you're using a smart shop, we have the smart shop with the automatic tool changer. If the smart shop that you're using has a BNR controller, you can use a BNR, or if it's not if the other controller, you can just pick ATC, and then you pick OK. So that's the machine, the post, the stock material is defined. So we're now ready to create some machining operations. So we'll go into machining operation in here. We'll pick 3 axis. Since the part has sculpted features in here, you typically want it to do a 3-axis operation. You cannot just do like a 2D operation. So we'll pick 3 axis, we'll pick roughing, and then we wanted to pick the boundaries to contain the toolpaths. I'm going to pick these 2 as the boundaries to restrict or contain the toolpaths to. We'll pick a tool. So typically you may want to start with like a roughing process. So I could use a 1/2 inch cutter, which is like a 12.7 millimeter. Specify feet and speeds. Clearance is for your transfer motions, non-cutting motions, the clearance height. It's set to automatic. You can establish your cutting parameters in here. You can set the tolerances for roughing, the amount of stock to leave after it's being roughed. You can choose your cut patterns like the step overs, the cut pattern, cut direction, cut levels, how much material you want to take out per pass. You can also control your engage and retracts and all the parameters, and then pick generate. So in this process, it looks at the stock, looks at the part that you have, and then since we also picked this as the boundary to contain the toolpath stays to that boundary. So now when I go ahead and hit the play button, it runs the simulation, cut material simulation in here. You could always do a speed up the simulation in here. So that makes the simulation go faster. So that's your cut material simulation. And at any point, you can also do a pause and then click simulate to end, which will run through the simulation.
Okay.
Okay, there's the simulation of the roughing toolpath.
Right.
Now, if you decide to make any changes, you can again go back and re-simulate the toolpath. So if you make a change to any of the parameters, so for example here, I would want to go back in here and say the amount of stock I want to leave is just 0.5 millimeter instead of 0.6, or I can just then do a regenerate. The toolpaths will recompute, and then you can go back and run the simulation again. Any questions so far, sir?
Not yet, but I do have some.
Okay. All right, so let's go back and run a simulation again, so you can see that I'm running the simulation for it. We'll do a pause, simulate to end, run through the simulation. So the roughing is completed. In the next step, we want to do some finishing operations in here. So we could start with an operation called parallel finishing, parallel, and then again, I can pick these two as my regions. So select curve edge region. I can select these two. Then pick a tool. So typically you'd want to go with a ball mill. You can set your feed speeds, your clearance, exactly like how you did for the roughing operation. You can set the tolerances. Stock to leave is 0, so it's going to finish it right to the surface. The direction of cut, the angle of cut 0 means the cutter will traverse following the part going back and forth parallel to the x-axis. You can control the step over in here. You can say how fine you want the cutter to step, and then pick generate. So in this process, this creates like a finishing toolpath. As you can see, it's following the 3D model, right?
Yep.
And now I can go to the simulate tab and then pick play to run the simulation. So that runs your 3-axis parallel finishing simulation following the contour of the 3D part.
Okay.
Now we can apply different colors during simulation. So for example, I can apply it based on the operation in here. For the roughing operation, I can pick a certain color. So when you run a simulation, you can pick the different colors. And then for the parallel finishing, I can choose a different color in here. So it makes it easier for you to see what's being machined as you run the simulation.
Okay.
You can also speed up the simulation if you'd like to by changing the interval in here to make it go faster. Also, we can hide the toolpaths as you're simulating it. So this method is known as 3-axis parallel finishing, and you can control the cut direction. So in this case, we chose to go parallel to X. If you wanted to go parallel to Y, you can change it to 90, or you can even put in like a 45. So you can change the cut pattern or cut direction.
Okay.
So this feature is included with our standard configuration. Now we have additional types of 3-axis methods. We have advanced 3D toolpath methods like a 3-axis offset pocketing. The advanced 3-axis methods are available in the Pro and Premium configurations of the product, and I can show you how this works as well. Any questions so far?
So ideally, we would want to mill, let's say multiple parts per run. We would be able to save multiple jobs and run them at the same time?
Yes, you can program like 10 different scans into one sheet, and you can program them all together, and you can run it, and you can do a post process here, and
Okay.
all of those will be output in one job.
Yes.
So in this
Okay.
example, we only picked one pair, but if you wanted to do multiple pairs, you could do that as well. So you just have to lay them out within your sheet at a stock dimension, and then you can program multiple parts at once.
Okay. Now, at no point do we have to worry about any type of G coding, correct?
Yeah. So once you generate a toolpath, this is what we call toolpath generation. Once the toolpath is generated, you do what's called a post-processing. Post-processing is the step which converts the toolpath to a G code that will be compatible with your machine tool. In this case, this happens to be a Laguna machine. So post-processing converts the toolpath into a G code, machinable code.
Okay. All right.
Okay.
Got
and
it.
the nice thing about working in Rhino is saving your file in Rhino will automatically save both the CAD, the design data, as well as the machining data into Rhino.
Okay.
Now, if you're going to be using the same workflow and same process on all the other, scans that you're doing, so rather than having to go through this workflow by creating each and every operation, we can save these to what's called a knowledge base. So the workflow of operation will be saved into like a template. So I'm going to click on Save to Knowledge Base, hit Save. So the next time I bring in a new scan, once I bring it in and then I arrange it, as you can see right here, we prepared it. You don't have to go through the process of recreating these operations in here. You can click on Load Knowledge Base, and then we will go ahead and load the knowledge base we prepared. And all I have to do in this particular case is I'm just have to repick these boundaries in here for containment and generate the toolpath. So you can automate your workflow. So it has information on your tools, your feeds and speeds, your cutting parameters. All of this is within your knowledge base.
Okay.
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 So in this particular, sorry, go ahead, sir.
Yeah. So let's say if we wanted to modify this this file, we wanted to make that let's say the heel area a little bit higher, a little bit deeper. Could we do it, or that would be on the design aspect of it, right?
You want to make this deeper? You mean you wanted to bend it, or you want to modify the design?
No, well, make like a heel cup go a little higher.
The cutting, you want it to go higher?
Yeah, like to leave the because usually we do which is called the heel cup, leave it sometimes a little higher, or a little deeper. Could we do that?
Yeah, so you'll have to make that change in the design, and then the machining is generated for what you've designed here. So you'll have to modify that in the design. Now, I can set it to leave some extra stock in here, but it'll do a uniform. So if I put in, let's say, 0.2 millimeter, it's going to take the entire path and offset it up by 0.2 millimeters. So it's going to leave 0.2 millimeters uniformly all on the entire surface. But if you only wanted to do in a certain section in here, then you'll have to modify the design.
Okay, so which is basically at the CAD at the beginning portion of it.
Right, you'll have to do it in the, yes, that is correct. So
all right.
The toolpath is generated for what you already designed, right?
Right, what is going to be milled out, yeah.
Right. So in the Pro configuration, you have some advanced 3-axis methods, like what's called a 3-axis projection pocketing. So I'm going to pick the same ball mill tool and generate a toolpath. You'll notice that now the toolpath here, it follows a offset pattern of the shape of this geometry, as you can see, as opposed to just cutting it in parallel planes. So you have more options in generating 3-axis toolpath, and this comes included with the Pro configuration. Like, for example, you could do the 3D projection pocketing or even the 3D offset pocketing, which does a constant 3D step over.
Okay.
So you have more options or more ways to create finishing operations, which comes included in the Pro configuration. So
Okay.
you have more control. If you want the toolpath to go a certain way, you can, have more precise control. You have more choices in the 3-axis methods in the Pro. Now,
Right.
you also have a need to machine the part from multiple different sides, like machine from the top, flip it over, do machining from the side, bottom.
Right.
Okay. So do you have a need to do that? Sorry, I missed that.
Yes.
Okay, all right. Now, what I'm going to do here is I will go ahead and give you an example of, a couple of other parts. You asked about how we can, machine like a foot scan, the actual, foot itself, right?
Yes.
Okay, so let me go ahead and look for an example here. While I'm trying to do that, now, do you have any other questions I can help you with?
No, not at the moment.
Okay, all right. Give me just a moment here, sir. Okay, so I'm going to go ahead and bring in an STL sample that I have, which is actually the model of the foot itself.
Okay.
So you notice that, sir?
Yep.
Okay, so would it be something similar to this you're looking to machine?
Yes. Obviously just a planar surface of it.
Okay, just you mean the bottom here?
Right. But we
Okay.
obviously need it to be, at least up to kind of the ankle.
Okay.
Yep.
So which means
Yep.
you will need to bring in the scan the way it is. That you just need to do the inside portion, or you want to do machine this side from this side?
No, from that side, yeah.
The where my cursor is that correct?
Yes. Yes.
Okay. So I got this part loaded in here. So let's go ahead and take a look at the dimensions.
Okay.
Okay, so that seems to be okay if it's in millimeters. Okay, I just wanted to make sure that it wasn't too big. So now,
Right.
typically I would do a rotation of this part to line it up the way I want it. So I can use this gumball here to rotate it. I could say rotate it minus 90 degrees, right? So now if you look at it from the top view, it looks the direction you want to machine the part from, right?
Right.
Okay, and if you wanted to trim it or split it to a certain height, you can use we have a module called Mesh in RhinoCAM. That's an add-on module which will allow you to actually split it. So you can go into the Mesh module, select RhinoCAM and Mesh, and we have tools in here where we can do a split of the mesh. I can select this model and I can choose where I want to split it. So you can see I want to split it at the ankle, or right here I can use these controls to where I want to split it, right?
Yep.
And then I can say I want to cap it or do not cap it. When I say cap and split, it's going to actually take this and split it into 2 halves. So you can see there's the lower half and there's the other half. So
okay, yeah, yeah, that's all we need right there.
Okay, so you can use the mesh module that'll help you in splitting, and then I can basically even delete this out. If you don't need it, I can do a cut to delete that portion out. Okay?
Okay. All right.
Now I'm going to go back to the mill module. So I only have left half, so you can do the same thing for the right half as well, or one of the foot here. It could be the right side, sorry. Now you want to machine this, the workflow would be very similar.
Well, here's where it gets a little tricky with that aspect of it. Once we're milling a positive of a foot, we actually need to modify this positive to some degree. Let's say that we wanted to make that heel a little bit wider, like let's say 3 millimeters wider. Could we do that here?
Just the heel, or do you want to do the entire thing?
Well, it's the entire is the we usually expand, which we call it expansion on the heel 3 millimeters, the lateral side, and on the arch area, we make it 1/8 of an inch lower than what it is.
Okay, so you will have to do all of those editing in the CAD itself in the Rhino. So if you want to, you may have to do some splitting and then machining it, because right now it's one single mesh.
Right.
Let me go back in here to the mesh module. Let me undo what I just did.
Okay.
Okay, so let me undo this again. So if I do a split, I can pick this and do a split. I can pick where I want it to be split right here. And I can say
Okay.
do not cap this. So if I say do not cap, it's going to leave the lower inside section hollow.
Okay. Oh, no, awesome.
So it's going to leave it hollow. And now I can, you know, if I wanted to basically just, you know, modify a certain section in here, you'll have to again split it and modify it. You got to use the tools. There are also some third-party plugins available for Rhino that could be specialized for orthotics. So you may have to investigate into that. There are plugins available for Rhino as well.
Okay.
Okay. So here I can do an offset of this open mesh in Rhino. I can take this, and there are some tools called mesh offset, mesh edit tools. Let me see here. There should be a command. So if it's an open mesh, you can offset an open mesh in Rhino. I can call it mesh offset. So let me see here. Okay, offset mesh. So I can pick this mesh, and then I can specify the offset distance. You can choose to offset it either both sides or one side only, and you can specify the offset distance in here. You can see it's shrinking it right here, right? You can see the mesh is shrinking.
Yep.
I can say flip, so it's expanding it. I can offset it by 3 millimeters. So it's basically offsetting it. I can say delete the input mesh. If I say do not delete the input mesh and offset it, we ended up with two meshes. So you can see that there's the original mesh and the one that we offset 3 millimeter.
Yep. Okay.
So you can offset the mesh using the native tools that you have in here. And so you can see this is the inside one and that's the outer one. So we did a uniform offset all around it.
Yep.
So there are different tools available, and there are also some additional you know, plugins that are available in Rhino which you may have to look into that is specialized for your needs. Okay.
Okay.
So RhinoCAM will help you. RhinoCAM's mill module will help you, you know, create the G code for machining, and then the mesh module in RhinoCAM will help you do some mesh editing, like mesh trimming, mesh splitting, mesh inspection, repair. If you want to do the offset in individual areas, then you may have to use some of the native Rhino tools, or use you know, some additional plugins that you have for Rhino that you can use for it.
Okay.
All right. Okay, so now that we have this, I can go back into the mill module here, and then we define the stock material. So we can look at the stock size. I'm going to put in maybe 120 by 300, and I'll make it 50 millimeters. And now we are ready to align it. And then we can establish the 0. So very similar to what we did on the previous step, right?
Yeah, right.
So we established a 0, 0 right there. Now, rather than creating the toolpaths right from the scratch, like we talked about using knowledge bases, I can use a knowledge base from the previous part we worked on here, which is the STL test. So we have this knowledge base right here. And now if I just generate the toolpath, it's going to compute the toolpath based off the part and the stock automatically. And again, I can go back and run this parallel finishing operation as you see it. So it's generating for this particular model. Now, if you want to contain the toolpaths, again, you can do what is called a mesh outline command. You can use this mesh outline to create the boundary around the part. You can select this, it'll create a boundary. I can also do a simplify curve, rebuild the curve into fewer control points in here. And then I can offset this curve by a certain distance. I can say offset it out by 5 millimeters. So it gives you a nice little boundary here. And then for the toolpaths, I can go ahead and select that as my area to restrict or contain the toolpaths.
Okay.
So you're not turning everything around it into chips, right? So
yeah.
And then I can apply the same for the parallel finishing also. Now for the roughing, I could say, let's not pick any boundary here. And then let's put a cut level at the bottom. So instead of going all the way down to 50 millimeters, I can keep it 5 millimeters above right there. So you have something for it to, if you have a vacuum table, it'll be able to leave a little floor on the bottom of the part.
Right.
Okay, so let me do a pause here for the simulation, and I'm going to run the simulation in a little faster speed, so it just makes it easier for our demonstration purposes. Okay, so you can see we left 5 millimeter down at the bottom. Now for the finishing operation, I can use this boundary in here to contain the toolpaths too, and then generate it. So I'm cutting it along the X, as you can see, parallel to X. I can change the direction to go 45 degrees as well.
Okay. Yeah, because this way it would take would it take a little bit longer to mill if you're doing it the X versus doing it Y?
It shouldn't take a lot. The time, you can look at the estimated time. If we go to information, let me pause this here for a moment. Let's go right click and do information. So we're cutting along X. It's estimating if I'm cutting at 600 millimeters per minute, which is, I would say, significantly slower in terms of feed rate. It's going to take about 28 minutes. If I change the direction here, I'm going to go ahead and change the cutting direction. Let me go back in here and say copy and paste. So let's make sure we cut one along X. We cut the other one along the Y. We're going to change the angle to 90 degrees. We'll pick the same geometry for containment. So if you look at the information, you'll see it's pretty much in the same range. Yeah, it's not going to make a whole bunch of difference.
Is that obviously we can speed that up and make it a little faster, right? Than 28 minutes.
Absolutely.
Yeah, I'm looking to average more around the kind of the per pair, maybe 5-6 minutes if possible.
Absolutely, you should be able to do it. 600 millimeters per minute is significantly slow for orthotics. I just used the feeds and speeds that are in my tool library, so I haven't fine-tuned it for orthotics.
Okay. All right.
Parts. Yeah.
Okay.
All right.
Okay.
Any other questions on the demo I can help you?
Yeah, I mean, obviously, I think you did show us how to obviously cut the bottom portion of the foot, and we want to do the same thing. Kind of, we don't need the toe area of the foot. That's kind of, I would say, excess that we wouldn't need to generate some orthotics.
You can split the model. So I can go ahead and say I want to split the model here. So if you want to split it, you can split in any plane. So I can go back to RhinoCAM-MESH and we can say split, and I can pick this object to be split, and I can choose where I want it to be split right here. So if you're only interested in cutting the heel, I can say split it right there. So right now I have 2 halves. So this half,
Right. Yeah, I would obviously it'll be a little higher than that. It would be kind of you're familiar with the metatarsal heads are, and yeah.
Yeah, so you can basically pick a point where you want us to split it, and you can even pick that point for reference. So I can pick a point in here. So for example, I can say this is the line I want to create, maybe around this part right here, right?
Right. Yeah. A little higher on the medial side. Yeah. Let's just go stay there. So
what we can do here is now I can use the this is the other mesh we had. So I can do a split, and then we also have the option to pick a point on the model. So I'm going to So you can see I can pick the point right there and do a split. So it splits the model right over here.
Right. Yep.
Then, yeah, we could also do a split and a cap. If you wanted to cap it, it'll cap it. In this case, I only did a split. So yeah, you can choose.
Okay.
Also, there are tools available. You can do a combination of different tools. If you wanted to split it in a certain way, so for example, rather than doing it this fashion, I can actually model something here. I can say the split needs to go something like, you know, I'm just going to go throw in something like this, right? In a curved area like this, you want to split it.
Yeah.
So there are commands. You can do mesh split in Rhino. You can use a combination of tools that are available in the mesh module in Rhino and the native mesh tools. So the object to split is this one, and then the cutting object is this. So now you can see it's being split in this fashion.
Okay. Yep, that works.
Yeah. So you have, you know, a wide range of tools that are available for your, you know, editing and also machining. Now, if you feel that just a parallel finishing cut pattern, the toolpaths, what you're seeing here, this is good enough, and if you would like also have the ability to do some advanced 3D machining toolpaths, then the Pro would be ideal. If you think you just can, you're just going to be using parallel finishing, then this can be done with the standard configuration as well.
Okay.
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 All right. Any other questions before we wrap up the demo for today?
Just a quick one. As far as you know, the file itself that we're using. Let's say that we want that that scan to sit a certain way. You know, we're always trying to put it into kind of neutral position, which means there should be three contact points, which is that center of the heel should always be contact. The distal part of the big toe, or the first metatarsal head, and the fifth metatarsal should always be the points where they should be touching first.
Okay, you mean in terms of the XYZ placement you're talking about?
No, that's just, you know, for the design aspect of the mold.
Okay, so you may want to look into talk to Rhino. We can provide you a contact at McNeil, and they might be able to help you more on the design part of things, design side of things.
Okay.
Because our strength and expertise are on the machining side. I did go ahead and show you some of the mesh editing tools, but if you need more help on the design side of things, I can certainly have you reach out to McNeil. They are the developers of Rhino, and they can provide you some guidance on it.